This is Professor Derf Seitz. This Java tutorial is part 2 of File.io, and it shows how to read a structured text file and to write out to a text file. It uses some classes that were shown in the exception tutorials, in particular the calculator class that calculates, add, subtract, multiply, divide, and some special versions of divide with exceptions and with validation. A calculator expression class that is the textual representation of a requested calculation, an operand, white space, an operator, white space, and the second operand, binary operators. And this time the client, or the main application runs from, is called batch calculator, because it's going to read from a batch file where the calculation requests are batched up in a text file. Here's what that file looks like. Each line is a simple calculation request with an operator and two operands. 1 plus 2, for example. And the divisions, we have normal division. Divide with E means that's a division that will throw an exception if there's a zero divide. And divide with validate will not throw an exception. It will return NaN, the double, not a number. All these operations are done with doubles. And we'll go back to the code because we want to focus on here is the File.io aspects of it that have been added. Last time we showed these classes working together, we used an array of strings to hold the calculation request. This time we see here first we're going to create a batch file scanner. So we give the name of the batch file here, batchcalculations.txt, and we create a new file with that as the path name, and then we have a scanner called batch scanner, and we want to create an object, so we do a new scanner and give it the batch file, the file. We have to put that in a try block because exceptions come into play when you're doing File.io. Here there could be a file not found exception that's a checked exception that we have to either catch or rethrow. We have a catch clause. If the file cannot be found, we print out an error message and get out of the program. Next, we create a results writer. We give the name of that file, calculation results.txt. We have a file with that path name, and then we have a print writer called results writer, and we instantiate that using that file. The default here will be to write from the beginning of the file, not append to the end. There's a catch clause as well here, and if we come into here we say unable to create this file, there's something wrong with the path in that case. So we have these two files. Well, actually we have a scanner attached to an input file and a print writer that's going to write to an output file, both text files. The input file is structured text and has the calculations as we saw, and the calculation expression and the calculator give us our support to handle all that parsing. So next, as we saw in the previous showing of these classes, we instantiate a calculator and a calculation expression objects. Then we have a while loop. While batch scanner has next, we create a string called expression and batch scanner next line goes into it. So we get one line and put it in our expression. We set that as the expression for our calculation expression, and it does the parsing inside that class as we looked at in the exception tutorial. And if its valid state is false, valid as false, then we want to ignore that line. Actually, we won't totally ignore it. What we'll do is we'll print out to the console that it was invalid. It'll show up on the console, and we will also write it, that same invalid calculation expression plus the expression, to our results file with the PrintWriter println function passing in that string. So it will be shown on the console and it will appear in the output file. If it is valid, we go down here and get all the information that we need and switch on the operator. Of course, we use the calculation expression class to do all that, the class that parsed it. And we go through and call the calculator to do the calculation, get that in result. And when we come down to the end, we display on the console the results of the calculation and also print out to our PrintWriter the results as well. So this while loop will keep going and going through the input text file. The classes will participate here for the parsing and the calculating. And then finally, when the while loop finishes, down here, we're going to have to close our PrintWriter because the PrintWriter has a peculiarity. Most of the constructors that are convenient, it does not do automatic line flushing. So the output is buffered and periodically will be put out, but not every time you do print lines. So if you don't close it, you're going to lose some data. I can show that, but we don't really need to do that part of it. If I remove this close, there won't be any output at all in this file. There wasn't enough to fill up any buffer, and we'll lose that output. But we are going to close it. An alternative to closing the PrintWriter is to call its flush function after every time we do a print line. To keep the code simpler, we just close it here. We're now going to run the program. And here on the system console is the results showing all the expressions, the calculations, and their answers, like 1 plus 2 is 3.0 as doubles here. And some of them were invalid. A plus B, that's not valid. A and B have to be doubles. 1, add's not an operator. A plus nothing, there's nothing over there. So it did find the invalid ones, and the valid ones it gave the answer. Notice this one at the bottom, 1 plus 2 plus 3, this is just a simple binary calculator. It only takes 2 operands, not 3, so that was invalid as well. Now we're going to open the output file and look at the output file. Here's the output file, open, calculations.txt, and it appears exactly the same as the system console because the same output was output to both places. So we're going to close that and go back to the program. Well, here's the input file. We'll close that as well. And back in the program, again, we see here, reviewing, that we used a combination here, a scanner tied to a file to get input, and also a PrintWriter specified with a location, a path name to write out, and we had to use some exception logic in there, and the parsing was done by classes that we looked at previously to sort of make the code less complex. You break things out into classes. That's good object-oriented design. You don't try to code everything. Try to have one code that's doing the input, another code doing the parsing, another part of the code doing the calculations and doing the output. So a lot of times you'll see in textbook examples where everything's all put together and sometimes it looks very complex. In real world examples, when you're dealing with more sophisticated programs than simple small little one-page things in a textbook, you have to break things out to be able to even maintain the programs. Here again is the input file, batch calculations.txt, showing that it is structured text. It did require parsing it and pulling it apart, and we used a combination of exception handling and file I/O classes in object-oriented design to build this program to do this calculator functionality.